Aloha, Richard Halverson here. This is ITS128, first class of the semester. And today I'd just like to introduce you to the syllabus and how the class is going to be run. And maybe I'll do a couple of exercises just to get you started. So let me start out by sharing my screen. Let's say I got to do this. I got to do this. I got to do this. And I want to. You probably can't see this, but I'm gonna move this out of the way. And you might be able to see this. I'll move this up. Okay. All right. So I can have to be there. All right. So this is if you go to La Lima, you should see this syllabus, and there are actually 3 versions of this class. And shoot, so I want to show it. It's too late. They're all going to be taught together. I'm teaching this class with Mr. Teho Yum. He's in charge of one of the sections, and we're kind of put everything together and share on the teaching responsibilities. And this class, it's an introductory Python class, and this is the class that you take if you want to go on and get a bachelor's degree in information technology from West. Well, you get a 2-year degree from KCC, or you can go on, leads right into a bachelor's degree in information technology that you can get at West Oahu or Maui. And then from there, you have enough of a bachelor's degree in computer science, so you can go on and get a master's degree in computer science and all that. You can do that with this degree. If you were to do that, for example, at Manoa, you would still have to take a couple of undergraduate courses in ICS, namely ICS 311, which don't take that unless you're planning on going and getting a master's degree in computer science. But otherwise, it's a very strong, powerful degree. These days, 2-year degree it used to be you have to have a 4-year degree for everything. It's not how it is, especially in IT anymore. So you're in the right field and at the right time. And so I would like to see a course like this become a more general course, just similar to ICS 111, ICS 101, which everybody has to take. It's about computers. We're going to be deprecating that course probably pretty soon, because everybody comes into college now knowing about computers. So we may do that someday. So in this class, this is not going to be a rigorous computer science class. It's going to be a class where I want everybody to learn Python. And you might at the end of this class say, hey, programming is cool, I get it. It's not for me though. I like IT, but I don't necessarily want to be a programmer. Well, there's lots of other roads in IT that you can take, stay in IT, but not necessarily be a coder. So that's kind of what this is. And now we're seeing Python everywhere. I mean, we're seeing Python in all of the career technical careers now. There's there's Python in the kitchen, Python in medical facilities, and so on. So it's a good course like that. What I'm getting at is I don't want to ruin anybody's career taking this class. Okay, so just do the best you can, and you can decide yourself whether you want to take ITS 148. Then after that, maybe ITS 228. So this is the syllabus, and you can look through this. Every Tuesday, I will be recording this session. I hope this recording works. So you can tune in if you're asynchronous in any section. You can tune in. You can also come here too. There's 22 workstations here, and there's only less than half of them are being filled. And if you would like some face-to-face help, just come on in. We offer this not only for, we offer this, okay, a lot of the motivation for having a face-to-face session is because there's some students that that need a face-to-face class to be enrolled, and international students and military folks that are getting a housing allowance, they need a face-to-face class, and so we offer that for them. There's also the students that like to have face-to-face classes. That's not so important in some of the EMT or culinary, where, you know, how do you teach someone how to cook, you know, without the person being there. Here we can go online, but still people like face-to-face. So anyway, so everybody's welcome, and we don't need to limit the size of the classrooms. So you in the classroom, if you could log in here, you can kind of see what's going on, because, oh, well, I guess you can see it up there too. All right, so if you come to the class here, you have the benefit of two huge screens over here to watch it. Weekly engagement. We need to do this weekly engagement thing, so I know that you're going to take the class. Now, some instructors like to give you an assignment, and if you don't do the assignment, you don't get credit for weekly engagement, and then you can get disenrolled. Well, I have a problem with that. First of all, if I disenroll you, first of all, if you did work and then I disenroll you, I mean, it's like, well, you paid for something. Oh, but you paid for it, you did something, you didn't get, now you're not enrolled. Well, then you should get your money back, okay? And I think you would have a very good argument if you get disenrolled to go and get your money back, because you can say, hey, well, I didn't even. So I think that sometimes people are late getting started and all that. So if I can find evidence that you have logged into Laulima or done anything, I will not mark you to be disenrolled. And so I can actually go in and see if you've logged in. I don't do that unless you neglect to do participation verification. The easiest thing is if you just do participation. You aren't going to get any credit for it, but it's a way that I know that you're going to be enrolled. Another thing you can do is you can buy the textbook. I also go in there. If you've paid $89 for the textbook, I'm not going to disenroll you. Okay, I'm going to say, well, you know, hand it in when you can hand it in, or whatever. So, but it's important that I know that, and all you got to do is go in here and go, oh, let's see. Okay, this is the student version of Laulima, that kind of like how you should see it. And so I'm going to go. I'm here to take the class, or anything, just anything. Hi there. Proceed and submit. There. Now I won't get disenrolled. Okay, and announcements. I think there's going to be announcements there. I'm not big on announcements, but there's two of us teaching this class, and there's going to be some announcements. This is where you go to the textbook. You click here. And you let's see, I have a student version, don't I? Oh, I haven't started up this one. Okay, so this is what it looks like before you pay. And and you actually get the first chapter. But don't do work here. I mean, so you know, you can do the work, but you have to do it again after you buy it, because if you do the work here before you buy it, then once you buy it, I don't see it. So, you know. But so today you can follow along here if you have not registered yet. Okay, so let's go back to, okay, so that's that. This is the grade book. Okay, so this is how the grade book works. There are these things called participation activities in books in the textbook. There's 12 chapters to the textbook, and these are the points here. The second, and then there are these challenge exercises. There's challenge exercises in every chapter, and then there are these chapter programs at the end. And you'll see all these in a moment. But I have like one lab that you have to do out of each chapter. Okay, and that's so you get exposed to every chapter. And then after that, there's more labs, because actually 8 labs. These are short labs; they don't take that long. So 8 is really not enough for this course. You should take more. So maybe 16 is a good number. Okay, so there's, or maybe it's 20. No, it's 25. It's 25 total labs that you're going to do, I believe. So of these here, I'll drop the lowest 8. So I think there might be however many here. There is 17 or something. So I dropped the lowest 8. No, there must be 13. Well, anyway, so when you add up all the ones that count, there's 25 of them, and that totals 50%. So each lab is a total of 2% of your grade. The challenge activities, you add them all up, and that's 30% of your grade. The participation activities, you add them up, that's 20% of your grade. The participation activities, you just have to click through them and you get the 20%. Okay, you just have to read. You read. You got to click through the animations, and there's little quizzes. But if you get it wrong, it says it tells you the right answer, and then you go and click and you get the right answer. So you just got to go through it, and there are these little things along the way to see if you've comprehended what you're done, or you've just clicked through it. But you can just click through it if it's like, everything is due, tomorrow, and you're at a high B, and you didn't do all the participation activities, and you just click, and then you're over, and then so I mean that's fine. Of course, if you're up there already, you're probably going to do well already anyway. So, all right, so that's those, and you'll see how easy those are in a moment. For resources, these are video playlists from previous semesters that I've taught this course using this textbook, and some of the chapters are rearranged, some of the exercises are rearranged, and because I can do that, but to be honest with you, I think every single lab and every single challenge activity is in a video. Okay, and I will actually try to tell you where they are. I have to update the spreadsheet. Sheets. 128. Resources. Why am I not logged in? Oh, I know why. Here, let me just log in real quick. Because you should be able to do this. Oh, no. I made a mistake. Okay. Oh, okay. So you got something like this. I'll update this because I think this could be last semester or something. But anyway, so these are YouTube videos from previous. It's all on YouTube. There's playlists. So it says which videos are, and it's set to go directly to the video. So it's great. You don't have to. Okay, so I try to make it easy for you. I try to make it that where if you put in enough time, then you can get all the points. Even if you don't, even if you're just following along and doing what I'm teaching you how to do, there's enough of it where you'll catch on and you'll learn if you like it. It's like puzzles. Sometimes some people like Sudoku and some people don't. Some people like gaming programs, and some people, it doesn't inspire them, just that kind of stuff. So it's the same kind of thing. You can be good at Sudoku but not like it, or you can be whatever. So that's there for you. All right, that was, and so when you sign up for that, and for email, you can send an email to everybody. You can see everybody. You can see everybody else in your section. Now there's other sections, and I don't combine sections here simply because there's a bunch of privacy issues with you're seeing who's in another class and they're seeing that you're in the, so but you can all see who's in this class. So that's what oh, by the way, this is probably the wrong section. Huh? Yeah, I don't think this is your class. This is probably the other, this is probably another one. Here, so it would be like it's this one is not this one. It might be this one. Oh, which one is this? Is 33438. I bet it's this. Is it? Is this class? Huh? Okay, so good. So this is this class. So you get to email all these people in this class. And oh, by the way, I don't care if you guys start having email threads and all that kind of stuff, you know. Don't send each other's code, but you can go all the way up to that. Okay, you can, you know, you can just as long as it has to go through their head and understand kind of what you're telling them, and then type it. And you can work together and everything. That's all fine. Hey, but that's how it is in the real world. Okay, that's so. Don't care about that. And then all the emails I've ever sent, you should be able to get them here in the archive. I'll confirm that because I don't think I've sent anything yet. Oh no, shoots. So that's just oh yeah. Any email I send to any class, I'll send to all the classes, so you'll see all the emails. All right, so let's take a look at the zyBooks textbook. Oh, I'm gonna go to this is my, okay, let me just log in to my other zyBooks. All right. Why don't I'm gonna well, okay, I'll just use this one. Okay, so these are the chapters, and I left all these optional ones in there. You'll be able to see all these optional ones, and I could put them down into an unused section, but the trouble with that is then they get all mixed up and I can't keep them straight. And so just ignore those. There's a bunch of optional ones. You're welcome to go and check those out. That's ITS128 stuff. So you can kind of look there, kind of see what's ahead. But this is the stuff you're responsible for. And so each sort of let me go to reporting. It's nice to see that. And so each chapter has got participation activities and challenges and labs. Okay. And so and one lab in every chapter is required. It's, you know, of course, well, yeah, it's required. If it's required, it's probably going to be in a video in someplace. So, okay, so let's start. Let's just, have I covered everything? Oh no, let me cover the grading policy. That's pretty important. Go here, overview. So this is the calendar. And so there's the weekly engagement there, and then it's just challenge activities and lab activities. See, there's 2 labs each week, and the first lab of each chapter is required. The lab numbers are some of the lab numbers will be different than in the videos because I moved around some of the labs because I want the first one to be required, and so I just want, you know, sometimes I might change the first one that's required and so what's lab 10.7 in an old video might be lab 10.8 in this video or in this class or whatever. So keep that in mind. The name, you can go by the names. And so this is the points breakdown, and of course these points are, these weights are different than these weights. These weights are the same as these weights. These are both labs. Because everything is auto-graded, I can only do this because everything is auto-graded. In future classes, I don't teach, not all my classes are auto-graded, and I can't do this for all my classes. But because it's auto-graded, these due dates are recommended due dates, but you can hand them in later, and it's there's no penalty. In fact, my grades are due Tuesday morning after the last day of finals. Okay, Tuesday morning after the last day of finals. So what's the last day of finals? It's like March 10th, May 10th. May 10th, is that the last? Oh, wait, there we go. Friday, May 10th. That's last day of finals, right? I'm pretty sure. And so my grades are due the next Tuesday morning. Okay, so that means Monday, I'm going to get up and I'm going to probably do this in the morning. I run all the grade. The final, I go into Zybooks, take the final, pull all the final grades down, and I put them in La Lima. I'll be putting them in La Lima every week or so. Somebody already emailed me and said, I finished chapter 1. Why don't I see my scores in La Lima? Well, now that I know there's at least one person that would like to see that, I will make sure I diligently do that. Either me or the other guy will do that. So you could, no, you probably couldn't because it's be physically impossible, but you could wait till, Friday, May 10th, all done with the other finals. You got the weekend, you haven't done one damn thing in this class, sit down Saturday morning, you stay up for 48 hours, you finish everything, make sure you get all the participation activity, maybe save that for anyway. And then on Monday I wake up and I run the grades, and you get all the points. That's of course that's kind of ridiculous, but I don't give extra credit, because just go back and do some more. It'll be week 5 or week 6, and you maybe not got all the challenge activities because whatever, or maybe you didn't get all the labs or whatever. Just go back and do those, and the later, of course, there's the advantages. The later you are in the semester, the easier the earlier ones were. So sometimes if you don't get it during that week, you go back 5 weeks later and go, it's easy now, and so that kind of stuff. So that's how I learned coding. I was not the stellar student that I was later on in life. Every 35-year-old student is a good student, but not every 25-year-old is a good student anyway. But some people, my daughter's great. My daughter's a good student. Anyway, okay, good. So I did all that. So let's just get started here. Okay, so here's the first chapter. I open it up to the first chapter. By the way, you can click over here and you can see this is a nice table of contents here. So we are on the first one, programming. Okay, so there's a lot of stuff that is just introductory that you probably know already from ITS128, and it's not really important. So this is a zip through kind of thing, but you still want to do it because you want to get all the points. Okay, so here, computer program. You click on 2x speed because it goes faster, and so the idea is you're supposed to follow along. There's a program consists of inputs and outputs, and then there's a process in between to take the inputs and turn them into the outputs. So when you define the requirements of the program, you define the outputs, and then you define the inputs, and then it's up to the programmer to go from inputs to outputs. You got to make sure that you can do that. So so let's start. And we say, okay, the first thing is read X from the keyboard. Okay, good. Now, and then read Y from the keyboard. All right, and then add X and Y and put it in Z. Oh, there we go. And then put Z out on the screen. There we go. So that's a computer that's right. And I got all the points. See, it's check mark up there. Here's some nice quizzes. How many instructions does the program have? It's got 1, 2, 3, 4, looks like. So I'm going to put 4 here. I think that's the right answer. Okay, good. That's right. I got the check mark. Suppose a new instruction were inserted as follows. Add 1 to z. Okay, so right after the z equals x plus y, we have another instruction that says add 1 to z. Z is the output. So okay, so what would the last instruction output be? Okay, so the answer is 5, right? See, the answer is 5. Well, I'm going to put the wrong answer just so you can see what happens. Bung. And then bung. Oh, I'm exhausted. Okay. Oh, it's 8. It's 8. Oh yeah, 5 plus 2, 7 plus 1 is 8. Okay, yeah, that's the answer, 8. So now I still don't have the check mark, so now I gotta actually do it. Okay. Oh, good there. So, and no one's the wiser. Nobody knows that I actually made those mistakes earlier. Consider this instruction: if x is 10 and y is 20, then z is going to be 30. See how easy this is. All right, program is like a recipe. It's actually, that's a very good analogy, and that analogy's been around for a long time. If you can follow a recipe, you should be able to code. You can read a program, and reading a program is half the battle. If you can write down a recipe, then, especially if you can write down a recipe of something you know how to cook, if you can do that and it's understandable by somebody else, then you can code. Okay, you don't get stuff out of order. You make sure you got to catch every. In fact, you can watch the person. Oh, you didn't tell me to beat. Okay, so you might have to do some debugging. Yeah, have somebody read the recipe a couple times to get it right. But anyway, that's exactly the same thing. But the computer is actually a really, it's like a robot. It's the computer is not going to get bent out of shape because just like a human might get bent out of shape if you are trying to teach them how to do something, but of course the computer won't. Okay, so let's run. It's a participation activity. Let's just run this, see what it looks like. So m equals 5. So put m equals m plus 2. Put it out there. M equals m times m. Okay, so here we're taking m and we're multiplying it by 2 and seeing what it is, and then we're taking m and multiplying the same the one we just added 2 to. Then we're gonna take it and multiply it by itself. In other words, we're going to square it, and then we're going to add 15 to it. Okay, so which instruction completes the program to compute a triangle's area? Which instruction completes the program to compute an area of a triangle? Area of a triangle is you get the base, you get the height, and you multiply the base times the height, and that equals x. Is that how you compute the area of a triangle? Okay. Don't you divide by 2 or something? Put x to output. Multiply x by 2, add x to 2, multiply x by 1/2. Does it tell you how to do the base of it? Okay, well, I think it's this. Is it this one? Yeah. Well, how do you know that? Well, I guess you just have to know that. Maybe you have to search the internet. Formula for area of triangle. Base times height divided by 2. Yeah, okay, well. All right, so that's what you got to do. But of course, if you got the wrong answer, you just click. It takes 3 clicks and you'll find the right answer. And then you get all the points. Which instruction completes the program to compute the average of 3 numbers? Well, that would be this A. Yeah, averages. Okay. Computational thinking. Okay, so this is important. This is the difference between programmer that programs in Python or a programmer that programs in database language SQL. And what it is it's computational thinking. If you're a Python programmer, you think about a process. You think about a process that steps that you go through and steps that you go through to get the solution that you want. So you're thinking of the computing part of it. Whereas the other kind of thinking, the mathematical kind of thinking, where, you know, what's the equation for finding the area of a triangle? Well, there's just one equation, one line, okay? Now, you can have, what's the equation for finding out the area of a huge something else, and it's not going to be a bunch of steps. It actually could be a bunch of steps, but it's not. The mathematician is not going to describe it in a bunch of steps. The mathematician is going to describe it in a big, huge equation. Okay, and that's what SQL is. With SQL, it's database language. Your SQL statement describes what you want the resulting table to be, and then the SQL engine inside figures out the steps to get from what you've described, taking that table and making it, you know, reducing it down and combining it with another table and taking only the ones that were the matches in the field, and all that can all be expressed in one equation. And some people are better at one than the other. If you're, and you know, it's up to you to figure out which you're better at. But I remember when I was getting my PhD, my dissertation chair was a mathematics guy. I mean, if you're in computer science, you have to take right along with ITS111 and ITS211, which are the two programming classes. That's very similar to our ITS128 and ITS148. Okay, so for computer science, you not only take the two programming classes, but you also take these other two classes, and they're called discrete math. Okay, 141 and 241. And that just teaches you like all the ways to count, you know, like how many, like, you know, you got 20 chickens and you wanna, you know, how many times can you grab, you know, and they all lay eggs. How many pairs of eggs can you grab where you make sure you get a different egg from each chicken? Well, that's a counting problem. And so you learn about how the equations for figuring that out. So it kind of trains you in both. But you're in this class, and we're going to be doing computational thinking. So when you write programs, it's not your job to write the equation. Okay, you get the equation from somebody else. You rely on somebody. Usually, you rely on somebody else to get the equation. So someone says, "Hey, I need a program to do this, and it's got to compute all this and that and this and that." Okay, you say, "Okay, well, you tell me what those equations are, and then I'll code it." And so a lot of this class is how to take an equation that looks like this, which is up and down, and how to make it be so it's all in one line. So anyway, so that's kind of where that's headed. Here's an example of another kind of test of computational thinking, and this is kind of a little bit how graphics work. It's a lot like how graphics work. So here's a program where these are the things you can do, and these are so this is using them, and 20 means 100 forward, 100 notches, left 20. So let's run this. And first it does the pen down and does the forward 100, left, oh no, these are degrees. I guess it's degrees. Well, anyway. So, and then you can change this around and see what it does. I don't know what this is going to do. It might, oh, whatever. Okay. All right. So anyway, that's that, but I got the points. All right. So that's, okay, so let's go back here. So that's programming using Python. So there's a Python interpreter. Now, so you can install a Python interpreter on your computer, or you can just You can usually, or you can do it all here. I mean, these have these nice little windows to execute Python programs. So here's a real live Python program. You have this variable called wage, and you set that equal to 20. Well, that looks like that's what your wage, it must be your wage, $20 an hour. Okay. And then you have this variable called hours, and you assign the value 40 to those hours. And then you have this variable called weeks, and you assign this value to weeks. And then you have this equation here where you take the wage and you multiply it by take the wage and multiply it by the hours, and you multiply it by the weeks. By the way, as you notice, the asterisk is the symbol for multiplication. It's not a little x, it's an asterisk. And so once this is calculated, you store that value into here. And then you can print that value out. So when you print that value out, you use a print statement. And first you're going to print some characters here that don't mean anything to the computer, but they mean something to the human, and then the value here. And then you can change one of the variables, and you got to recalculate it though. When you change this variable, it does not automatically change this. Sometimes some languages that's the, but not you have to execute this all over again. You do this. This is going to stay the same. You have to execute this part of it again before this changes, and then you get that. So if we run this, we can actually run it. See, and we're going to get this output, and then we're going to get this output. So here, if you multiply these three together, you get 4160. If you reduce the hours to 35, you get 3640. If we were to not have this statement, let's comment out this statement. Now that statement's not going to execute, and we run this. Salary is not going to change because we did not do this thing. Of course, we can change this to change the wage to 25 up here, and that's going to change everything. So anyway, that's so and you can also, let's see if it's installed on this, and I can go to CMD, and it'll bring up this works on a Mac too, but you may have to install it. So I'm going to type Python just to see if it's installed. Lo and behold, it is. There it is. Python 3.11 is installed. And once you type it, it comes up like this. So now, So now I have the Python interpreter running, and you can just type stuff like A equals 5, and then I can print, and I got to put in parentheses, I think, print A. Oh, look, there's the 5. And whatever, B, and A is still in there, so B equals A plus 10, and now we can say print B. See if this works in the space there. Oh, it does. Okay, so there's the 15. And then you can exit. You got to put the parentheses there, and now you're back to the regular thing. If you okay, so that's what's going on. That's what's going on here. The Python interpreter. Okay, so yeah, so we can type all these in. Yeah, so if you want, we can do that. Wage equals, okay, Python wage equals 20, and spaces don't matter. Hours equals 40. Oh, is that right? Oh, how long does this class go? Till 3. Okay, good. I promise I won't go past 3. I want to end earlier, but weeks equals 52. Salary equals wage times hours. I'm a minimalist. I don't like to type when I don't need to, so I just squunch it all up. People will tell you that looks terrible, but F them. And you can do double quotes if you want. Single quotes, there's a little bit of a difference, so you'll find that out later. And there we go. Salary is 4160. All right, great. But I still didn't get all the points because I got to do this. Should have put it on double speed. Can I do this now? Yeah, I can. Oh, there we go. See, there we go. And boom, check mark. All right. So here, look at this. A program that executes computer code is called the program that executes the computer code. Well, that's the interpreter. The text that represents a computer program. Well, that's the code. By the way, code is plural. Don't say codes, it's code. Informs the interpreter ready to accept. Yeah, but that's a prompt. A row of text, a line. Statement is one statement. An expression is what you see on the right side of an equal sign. The right side of an equal sign is an expression. You have a variable here, and then an equal sign, and then an expression. That whole thing is called an assignment statement. This, one line is a statement in Python. And you put the hashtag there to denote comments. Now, Python is different than most other languages in that one line is one statement. Okay, if you end a line by going on, you end a statement by going on to the next line. You can't put more than one statement on the same line. Okay, in every other language, a semicolon terminates the statement. So you can put as many statements on the same line as you want, as long as you terminate each statement with a semicolon. Okay, and you'll find out that indentation matters in Python. Indentation does not matter in every other language. You'll find that when people write code in every other language, they indent, but that's just because it helps them read the code. They don't need to indent. But in Python, you got to indent. If you don't indent, then it's a different program. Your code is the logic is different. Another thing in Python is that sometimes when you're using a text editor and you're typing code in, you have to know that lots of times you use a tab key to indent, right? You use a tab, it indents 4. Sometimes it'll indent by a single tab character. Other times it'll indent by actually putting 4 spaces in there. Okay, it depends on how the editor or the tool, the text, the thing that you're using to type your code. It depends on how that's set up. And so in Python, if you use 4 spaces once and then the next line you use a tab, it's going to look the same, but it's not going to be the same, and you're going to get an error, and you're going to say, "Why the heck am I getting this error?" And then you go and you use the arrow keys, and you figure out that one line is 4 spaces in and the other line is 1 tab character, and so that matters. So Python is a lot easier. A correct Python code is really easy to read because first of all it works, so the indentation, everything is right, and then to read Python code is real easy because the indentation really helps you, and in a way that's a reason why it's such a popular language. Okay, and then for input output, there's a print statement, which we already know about. That does output, print stuff out. You got to make sure you got quotes around text. You can put single quotes or double quotes, but they got to be consistent. So this one won't. This is not right because it's no quotes. This is not right because you got a single quote there and a double quote there. Matching, it's got to be matching. This one is right because the matching single quotes. And so I got my points. Okay, so here's a challenge activity. This is the first challenge activity. These are different. than participation activities. You can get through the you can get all the points in the participation activities by, you know, while you're sleeping, but not the challenges. Challenges, you have to be awake. But if you do a challenge activity enough time, you know, because, okay, so you get it wrong and it says, oh, sorry, you got to do it again. It'll give you different data. And then you get it wrong, sorry, you got to do it again, different data. Well, after about 3 of them, you're back to the, oh, no, well, it's sorry, you got it wrong. This is the right answer. Yeah, okay, now try it again. It gives you different data. And then it'll do it again. So, but after about 3 times, you'll see it's the same. It cycles back to the same problem again. So, you know, you eventually you should be able to get all the challenge activities too. But you gotta pay attention. You gotta read it and sort of understand what it's saying enough. So when if it comes around again, you can do it. But I have it set up so there's no limit to tries. And the reason for that is not because I'm a super nice guy, even though I am a super nice. It's because coding, trial and error is the way to do it. It's baby steps. It's like the best way to write code is like you start out by just a shell and you run it to see if it works. Okay, and so it's just the first thing it says is hello, and and then that works. Okay, and then you add a few lines and you grow your program that way, just adding a little bit of lines of code each time, and so you end up running it a bunch of times. But the thing about it is, if you add a little bit of code and you run it and it doesn't work, then you know it's just that little bit of code that you added. So it's real easy to isolate errors as soon as they happen. And so you'll see when I get to the labs, I can see how many times you tried to get this program to work. And if I see you tried lots of times, and that's good. If I see you only tried once, I could think that's bad if I made a rule that said you got to do everything, on the, in Zybooks. You got to do everything in Zybooks, and you can't work together or whatever. Then if on all your labs you only tried once and you got it perfectly right, well, then I'm going to get suspicious. But really, later on in this class, maybe not, but certainly in 148, we're going to rather have you develop your code on a real live integrated development environment like Visual Studio Code. You all should learn how to do stuff on Visual Studio Code. It's Microsoft. It's everybody. In all languages, everybody uses Visual Studio Code, and so there, you get your program running on Visual Studio Code, and then when it all works fine, you take and you copy it over, and you plunk it in here, and you execute it, and it runs perfectly the first time because you already got it to run on something else, and so that's a perfectly fine way to do it too. So they also do this in Zybooks. I'm kind of telling you this because a lot of the instructors around here use Zybooks, and some of the instructors do use these features, like they're able to tell you, like if students are copying each other's code and stuff. Well, that doesn't work so great for me because a lot of my assignments, I show, like my videos, I show you how to do it almost up to the very end, and then I leave the very end to you. So I give you most of the points, but then at the very end, get the last few points. You got it. You can talk to somebody, but you're the one typing it in. And so lots of times the first part of everyone's program looks the same because they just type what I did. And that's fine. That's fine to do that. These days, coding is a lot about knowing the right question to ask Google. That's important, and then taking something that's close to what you're trying to do, or maybe what you're trying to do is like this part. You find, okay, so I got to find some code that does this sort of, and then find some code that does this sort of, and find some code that does this sort of, and you find that, and then you take that code, and you just copy it right over, and then you mess with it a little bit to get it to work for what you want it to do. That's a perfectly good, fine way of coding. You want to make sure you test it. You got to make sure you know what you're bringing over, because it could be some weird stuff in there. And so to say you can't copy code anymore is not, it's not reasonable for us today in 2024. All right, so let's do this one. Write the simplest statement that prints the following. 3, 2, 1, go. Note white space matters. Make sure your white space exactly matches. So there's only one space there, one space there, one space there, and no spaces at the, okay. So my solution goes here. Well, I think that's simply, how about this? Print, quote, copy, paste, end quote, close parentheses. Let's see. Yoo-hoo! All tests pass. All right. Good. See how easy that is? Right? Which pair of statements print output on the same line? Okay, so what we're learning here is how to keep output on the same line. You notice, so here's, where do we do that? I guess we don't. Okay, here we go. So we have a print statement here, and it prints it. And then the next print statement here, and it prints it, but it prints it on the same line. It prints it on a different line because it's a different print statement. Well, how about if you want to have more than one print statement, but you want it to be all on the same line? Then what you do is you put this at the end of it. See, and this is going to end the line with a space, or this is going to it's going to end the print statement with a space instead of ending a print statement with a carriage return, with a return. So if you do it this way, hello there, my name is, with the spaces, then it's going to put a space in between. There's that final space, and then it's going to say my name is, and there's that final space. So, you know, so I know what you're thinking. How about this? Print of course, this is really silly because it's not the simplest, but I'm going to just show you that this works. Two, one, oops, one, go. And I do not want this last one here. So that should give me the same thing. Let's see if it does. Oh yes, all tests pass. Came out right. All right, so that's how you print stuff on the same line. And you can make new line characters with one print statement by putting \n in there. Okay, so this doesn't look very clear, but what it's doing is it prints a 1, and then \n means new line, and then it prints a 2, and then it \n means new line, and it prints a 3, and then since it's the end of the print statement, it does another new line. So that's what that does. White space is important. You'll see about that. See what's this. Oh, this is another kind of challenge. It's getting pretty late, isn't it? Shoots, I didn't want. Oh, this goes till 3 o'clock, not 2:40. Okay, so let's quickly do this. Type the program's output. Okay, there's a lot of these. Type the output. Note that print outputs prints an ending new line. Remember that's just reminding you that. Press enter or return on the keyboard after typing the output to indicate a new line in your answer. So make sure you do that. See here, if we're doing this, make sure you do this with the new line. If you leave the new line out, then you don't get the points. In levels 3 or 4, each comma is separated an item and puts a space in it. Okay, so now you learn that you can put more than one thing in a print statement. and it's separated by, and if you separate it by comma, it's going to separate what's printed by a space. I know what you're thinking. Instead of this, you can go like this. Oh, go like this. Watch how fancy I do this. You can do this because it's going to print the 3, then it's going to print a space, then it's going to print the 2, then it's going to print the space, just like that, which is how we want it. So it's see, look at this. Look, run, and lo and behold, I got all the points because it printed it right. All right, so let's do this challenge here real quick, and then I'm going to go do the lab. I'll get cut out of here and do the lab. You should learn about errors, but all this other stuff, computer tour, language history, that's all interesting stuff. But it's just good for history. Okay, so we got to press start. Joe is great. Okay, so it's gonna be Joe is great. Period. Enter. Fine. Check. Yoo-hoo. Got all the points. Look at that one. Next. Ron is good. Ron. Okay, so I'm gonna do the wrong answer. Is good. That's the wrong answer. Bung. It tells me this is what mine is. There's spaces here, and there's supposed to be returns. Okay. So next, got to do it again. It's the same question. Oh, they may really make this easy, don't they? All right. Ron is good. Enter. All right. Nice. Next. Person age equals 22. Each item in the output will be separated by a space. Bob is space 22. Enter. Bob is colon space 22. Enter. And the last one is Ron space, Ron is space 19 space years, period, enter. Right. See, it doesn't matter if there's spaces here, that just makes it look nice. It's this comma that makes it a space between this and this. So there we go. Oh, did anybody see that? Let's see if it makes me do the same thing again. Oh, now it's Joe. Boy, that's real confusing. Joe is 22 years, period. Oh, boy, that was close. All right, so that's all that. Lots of times there's a challenge at the end. You can, oh, they're teaching us input. This is how you read stuff. This is important too. All right, I better do, well, we're going to get all this later on. This is just introductory stuff. Chapter 12. Okay. Okay, so let's do the input up. Let's do the input stuff because we've done the output. Now we do the input. Okay, so we have here run a program and observe the output. Okay, so first of all, okay, so this says first we ask what the age of the dog is, and then we print that out, and then we multiply that. No, we ask how many. Age of a dog in human years, and then we multiply it by 7, and we get human years. Human year it is about that in dog years. So what happens if we run this? Okay, so the 3 is going to be the input. Can I change this? Oh, shoots, did I not? Oh, no, that's not the lab. Okay, shoots. I got to make sure that. All right, I'll get to that. Okay, so just don't get through these so we don't get confused. I'm confused. All right, so let's just run this, and the 3 is going to be what is input. Answer this question. Run. Okay, first it prints this out. And then this 3 here is your typing in the 3. Oh, no, never mind. That's not. No, it's not. No, it's not. This is printed out. And then the 3 there, you don't see it because it's going input. So you're not going to see it down here. The next thing you see down here is printing it. So it prints human years, which is 3. And then it prints the words human years is about. And then a space. And then it prints what dog years is. And dog years is equal to 7 times human years. So that's that calculation for. And so then it prints out the 21. And then it prints out a space because of that. And then it prints out the words dog years. That's that. Okay, and so this one is, okay, now I want to show you something. See, this to me is confusing. Okay, I think I can do this. I'm going to take this and I'm going to put it here. And I'm going to say X equals that. Okay, so first I'm going to input this X. And the thing is when I type a 3, I'm not typing the number 3. I'm typing the character 3. When I type 35, I'm not typing the number 35. I'm typing the character 3 followed by the character 5. Okay, so somewhere you have to convert the character 3 followed by the character 5. Somewhere you have to convert that to the actual number 35. It's got a value of 35. That's kind of confusing now, but you'll catch on later. But so if I do it this way, then I read it into a variable called X, and then I convert X to an integer. So it's like you're doing it in 2 steps. This makes more sense to me than having this inside of this. But you might see that later. Let me come back to this later and to try to reinforce it. I want to do a lab so you can see how to do a lab. Okay, so this is the first one, and I'm going to switch it to advanced. All right, so I am able to switch it to this. There's classic and advanced, and I don't need to go into the difference between them now, but classic is bad because it doesn't give you a realistic idea of what it's like to work with a regular old development system. It's reading the inputs and printing out the outputs don't look right because they're not interleaved properly and stuff. So so this is new for Zybooks, and I would like us to use this advanced interface, which you'll see when you watch the videos. You'll notice that they are more like what the challenge activities, what I just showed you. This is sort of a new way to do it. And by the way, if this doesn't really work out, then we can switch back to the other way. I don't think it matters as far as grading goes and so on, but okay, so let's try this. Okay, so this is what a lab looks like. And so you can get a various number of points, okay? So let's do this. It's 250. Most labs are designed to be completed in 20 to 25 minutes and emphasize a single concept. However, some labs, such as one large program or OLP, are more comprehensive and may take longer to complete. Maybe. So this is an OLP problem. It's certainly not going to take longer than 20 or 25 minutes because I only have 10 minutes. It's probably going to take 5 minutes. But what this kind of programming does is it emphasizes this incremental development. And that's kind of what I was telling you about before, where you take baby steps. When I was growing up and I learned programming, we used to call it stepwise refinement. Yeah, same thing. And so so that's this breaking it down into steps. And I'm always going to encourage you to do this. That's why those instructors that have it set where you can only submit it 3 times or whatever, I mean, that's I don't think those guys are real programmers. You know, I don't know, they like to exercise power on you over you guys or something. Okay, so it's good programming practice because you're doing a small amount of code at a time. Suggested process to complete longer is implement step 1 and submit it for grading. See, so here you even submitted for grading, you know, partially. And so that's what this is. It's 3 steps, and we're going to submit it for grading after each one. It's going to show us where we get partial points. We're going to write our code down here, it looks like. All right, step 1. Use the print statement to output step 1 is complete. Submit for grading and to confirm one of the 3 tests. Okay, so the output should look like this. Great. So add a print statement. Type my code here. Okay. Print. Step 1 complete. That's it. Run. Run. Oh, here we go. Step 1 complete. Oh, okay. It runs down there, right?
Submit for grading.
Huh?
Submit for grading.
Oh, submit for grading. Thank you. Yoo-hoo! Whoa, that's 4 points. Okay, very good. Uh-oh, but I didn't do, but it doesn't have that and does that because I haven't gotten that far. Okay, so let's with next one. Use a print statement to do this. Print step 2 as well. Okay, I'll do that. Print step 2 as well. Finishes it for you. And I will, as you say, submit for grading. And look, should do it step 1, step 2. Oh, I didn't run it. Well, anyway, I got all the points. I should run it though. Should run it. There we go. Step 2 as well. And the third one is print all steps are now complete. All steps are now complete. And I'm going to run it. Oh. And see, this is what it looks like, which is exactly what it's supposed to look like. And now when I submit it, uh-oh. Oh, what did I do wrong? What did I skip? What did I miss? Ah, no word R. Did anybody? Nobody? You guys are sleeping, man. Okay, I'm the one that's sleeping. Okay, now let's run this again. I know it does. All right, now I submit for grading. And lo and behold, I got all 10 points. And if I go back to here, I guess I can't see it because I'm the instructor, and this is what everybody, this includes everybody. And there's other people that have done it. Okay, there's other people that have, I think there's other people that have done this.
Under our assignments.
Huh?
Can't see what you've done in the under assignments.
Yeah. Well, here, see, I don't. Oh, let's see. Oh, let's see if this tells me. Oh, well, I didn't. Let's see. Let me refresh this. Well, this is good because I did 1 lab, right, and I should have gotten points. Richard Howard's instructor. That's me. Got all the points. Oh. Well, I wonder why lie in my library. Oh, all right, well, okay, everybody, try to do it. And if yours doesn't work, it could be because I'm instructor, I don't know. Some of you guys should try it. And let me know. Because this should say it's got this one right. Okay, well, anyway, it's 2:56. I will see next time we're going to go through chapter 2. If I feel compelled, if me or either Tejo feel compelled to do another video, we'll send out something on it. Are there any questions? All right, very good. So I hope to see you next week, but if I don't, see you on YouTube. Okay. Take care. All right, thanks for watching.